Hello students, welcome to our YouTube channel Experience Tutor. Today we'll start with class 11th physics. Get more than 95% marks series. Chapter System of Particles and Rotational Motion. Chapter 7 NCERT Line by Line Part 1. So let us start our lesson now. So chapter 7 System of Particles and Rotational Motion. Introduction. In the early chapters, we primarily considered the motion of a single particle. A particle is represented as point mass. It has practically no size. We applied the result to our study even to the motion of bodies of finite size, assuming that motion of such bodies can be described in terms of motion of a particle. So in this paragraph, from here to here, it is a simple paragraph just giving the introduction what we have studied. So you can ignore this paragraph because no practical questions can be formed from here, neither an objective question. Let us move to paragraph 2. A real body which we encounter in daily life has a finite size. In dealing with the motion of extended bodies of finite size, often the idealized model of particle is inadequate. In this chapter, we shall try to go beyond this adequacy. We shall attempt to build an understanding of the motion of extended bodies. And extended bodies, in the first place, is a system of particles. We shall begin with the consideration of motion of the system as a whole. The center of mass of the system of particles will be the key concept here. We shall discuss the motion of the center of mass of a system of a particle and usefulness of this concept in understanding the motion of extended bodies. So in this paragraph, it is said that what we are going to do in this chapter. So first of all, we are going to study about the system of particles, and mainly we will study about the center of mass and motion of the center of mass. These three things we will study. So nothing practical questions, no practical questions can be formed, just giving an idea that what we are going to do in this chapter. So let us move to the next paragraph. A large class of problems with extended bodies can be solved by considering them to be rigid bodies. Now here is the definition which is from definition of a rigid body, which is important. Of course it is important. So questions can be asked of 1 mark in various forms. So let us see the definition. Ideally, a rigid body is a body with a perfectly definite and unchangeable or unchanging set. The distance between different pairs of such a body do not change. So again, let us go through the definition. Let us underline it. Ideally, a rigid body is a body with a perfectly definite and unchanging shape. The distances between different pairs of such a body do not change. So, by this definition, two things are being said. So, first thing, rigid body. What is a rigid body? A body which has definite and unchangeable shape. And unchangeable shape. Second point, second characteristic of a rigid body is the distance between different pairs of such a body do not change. Here, the distance between any two points or the distance between any 2 points or any two rigid body pair or 2 is written, so no need to write pair. Rigid body do not change. In any circumstances. So this is the definition of a rigid body. So make a note of this, that what is rigid body. So first question we have encountered after reading till here. Now let us read further. It is evident from this definition of a rigid body that no real body is truly rigid, since real body deform under influence of forces, but in many situations the deformation is or are negligible. Thus, in a number of situations involving bodies such as wheel, tops, steel, beam, molecules and planets, on the other hand, we can ignore that they wrap, bend or vibrate and treat them as rigid. Now, till in this paragraph, we have encountered one question: what is rigid body? Let us move to the next paragraph. What kind of motion can a rigid body have? Let us try to explore the question by taking some examples of the motions of a rigid body. Let us begin with a rectangular block sliding down an inclined plane without any sidewise. Without any sidewise movement. The block is a rigid body. Its motion down the plane in such is such that all the particles of the body are moving together. That is, they have the same velocity at any instant of time. The rigid body here is pure translational motion. So here the example is given. In this paragraph we have taken an example that a block, a rigid body block here, is moving down in an inclined plane with the inclination as theta, which is inclined with theta with the horizon. Now, so what type of motion this block contains? It is translational motion. So in pure translation motion, at any instant of time, every particle of the body has the same velocity. So you have to remember the definition of translational motion. So what is the definition? At any point of time, every particle will have same velocity. Then the motion is called as translational motion. One more question. So one question we have encountered here, what is translational motion? So this can be asked in various ways. For example, they will give few examples and say, please tell us whether the motion of this body is translational or not. For example, they can ask that a block is moving, a wooden block is moving in an inclined plane. Please let us know what type of motion it is. So the answer will be translational motion. Now let us move forward. So till now we have encountered rigid body, translational motion and its examples. Now consider now the rolling motion of a solid metallic or wooden cylinder down the same inclined plane in figure 7.2. So here you can see same inclined plane with the same inclination theta. Now the wooden and the block is not moving, now a cylinder is moving, is rolling down. The rigid body in this problem, namely the cylinder, shifts from the top to bottom of the inclined plane and thus has translational motion. So in this case also it has translational motion. But in figure 7.2 shows all its particles are not moving with the same velocity at any instant. The body therefore is not a pure translational. Its motion is translational plus something else. So this paragraph is very important concept. So now we have taken an example of a cylinder rolling down the same inclined plane. Now let us consider few points P1, P2, P3 and P4. Now P1, what is the direction of the velocity? It is directed this way. What is the direction of the velocity of point P1? It is this way. What is the direction of the velocity of P3? It is this way. And what is the direction of the velocity of the body of the particle P4? That is this way. Are these directions same? No, it is not same. Therefore, the velocity of every particles in this case are not moving with the same velocity. So in this way this line is explained. Its particles are not moving with the same velocity. Remember, velocity is a vector quantity. So, of course, the magnitude of particle P1, particle P2, particle P3 and particle P4 is same. For example, if it is rolling down with a 4 meter per second, then all the particles are moving with the same magnitude 4 meter per second, but they have different directions. Due to different directions, they have different velocities, as velocity is a vector quantity. And since they have different velocities, therefore the motion is not a pure translational motion. Got it? Now let us move forward. So here also few questions can be asked in NEET, in IIT objective questions, as in objective questions, that and also in class 11, that they will give some examples of a solid body and they will ask what type of motion it is. You have to choose the correct answer. Now let us move forward. Now figure 7.2, they have given the description. Let us read the description. Rolling motion of a cylinder, it is not pure translational motion. Point P1, P2, P3 and P4 have different velocities shown by arrows at any instant of time. In fact, the velocity of the point of contact P3 is 0 at any instant if the cylinder rolls without slipping. Okay, another case here. If consider, I have given the example when the cylinder is rolling. So direction of each of the particle is different. Here they have also considered one thing. If the cylinder is slipping, not rolling, in that case also, if you consider the point P3, point P3 which is touched with the inclined plane. So point P3 is not moving actually, its velocity is 0 because it is because there is no displacement for point 3. So they have told point 3 is 0. The velocity of the point 3 is 0 in this case, in when the cylinder is slipping, not rolling. And when the cylinder is rolling, it has, of course, all the 4 points have different velocity because they have different direction, but the magnitude of the velocity is same. In order to understand what this something else, so here we have told that the motion of the translation, its motion is translation and something else. So here they are explaining what is something else. So in order to understand what this something else is, let us take a rigid body. So constraint that it cannot have translation motion. The most common way of constraint to constrain a rigid body so that it does not have translational motion is to fix it along a straight line. The only possible motion of such a rigid body is rotation. The line along which the body is fixed is termed as its axis of rotation. So this is conceptual line. What is axis of rotation? So take an example. Say you have a circular plate. You have fixed this circular plate in a wall by a nail. Then you can rotate this circular plate along this nail. So if you have fixed it, then there is no question of translational motion. But it has a motion that is called a rotation of rigid body. Okay, and the rotation takes place along the axis of rotation, that means along the nail in our case. If you look around, you will come across many examples of rotation about an axis. A ceiling fan, a potter's wheel, a giant wheel in a fair, a merry-go-round, and so on. So figure 7.3 A and B is telling some examples. So 7.3a, it is the example of a ceiling fan which is rotating along its axis. Again, next is ceiling fan. Next example B is the example of a potter's wheel. Potter's wheel is also rotating. Potter's wheel is also rotating along its axis. So two examples are given. Let us try to understand what rotation is. What characteristics rotation, or what characterizes rotation? You may notice that in rotation of a rigid body about a fixed axis, every particle of the body moves in a circle which lies in the plane perpendicular to the axis, has its center of the axis and has its center of the axis. So this is a definition, you have to remember it. So in your book, please underline this. In rotation of a rigid body about a fixed axis, every particle of the body moves in a circle which lies in a plane perpendicular to the axis and has its center on the axis. So this will give the detail of a rotational motion. Now figure 7.4 shows the rotational motion of a rigid body about a fixed axis. The z-axis, so let us see the figure 7.4. So this is 7.4, where this is x-axis, this is y-axis, this is z-axis. This example, in this example or in this figure, we can see all the three axes and the axis of rotation also we can see. So a rigid body, let us read the definition here, the description here. A rigid body rotates about the z-axis. Each point of the body, such as P or P2, P1 or P2, describes the circle with its center C1 and C2 on the axis. The radius of the circle R1 and R2 is the perpendicular distance of the point P1 and P2 from axis. A point on the axis like P3 remains stationary. So let us consider 3 points. P1 one point, P2 other point, and P3. So this is one point, this is other point, and this is another point, third point. So P1 is rotating along its axis, P2 is also rotating along its axis, and P3 is in the axis of rotation, that is in Z axis. Therefore, no rotation takes place for P3. So in the figure 7.4 shows the rotational motion of the rigid body about a fixed axis, that is Z axis. The Z axis of the frame of reference. So here we are taking frame of the reference as Z axis. Let P1 be a particle on the rigid body, arbitrarily chosen by at a distance r1 from the fixed axis. The particle P1 describes a circle of radius r1 with its center C1 and center C1 on the fixed axis. The circle lies in the plane perpendicular to the axis. The figure also shows another particle P2 of the rigid body. P2 is at a distance r2 from P2 is r2 from the fixed axis with center C2 on the axis. This circle 2 lies on the plane perpendicular to the axis. Note that the circle described by P1 and P2 may lie in different planes. Both of these planes, however, are perpendicular to the fixed axis. Now, however, fixed axis. Okay, from any particle on the axis like P3 r is equal to 0, any such particle remains stationary while the body rotates. This is expected since the axis is fixed. So let us see the image and let us describe what we have read there. So this is a rigid body. First of all, this is a rigid body. Now what happens? There are 3 points. Arbitrarily we have taken, at random we have taken 3 points, P1, P2 and P3. That is, the P1 lies at a distance r1 from its center C1. P2 lies at a distance r2 from the center, that is C3, that is C2, this is C2 whose radius is R2, and third point P3 which lies in the axis of rotation, that is Z axis. So here they want to say that they are P1 and P2 are at a different circles which is perpendicular to the axis of rotation, that is Z, and Only this has been explained in the last paragraph. Let us move forward. So what we understood? We understood from this paragraph that all the other points which are not lying on the axis of reference, that is z-axis, then are moving, but any point which is lying on the z-axis will not move while the body is rotating. Now let us move forward. So few examples, few figures are given here. In some examples of rotation, however, the axis may not be fixed. A prominent example of this kind of rotation is top spinning in place. Top spinning in place. Figure 7.5a. So let us see the figure. Yeah. So here the axis is not fixed. Sometimes when it is in the full speed, it is rotating along a z-axis, and when the speed is little less, then it is tilting down towards y-axis. So here in this case axis is not fixed for the top. We assume that the top does not slip from place to place and so does not have translation motion. We know from experiments that the axis of such a spinning top moves around the vertical through its point of contact with the ground, sweeping out cone as shown in figure 7.5a. So let us see the figure first. This 7.5a. Okay, in this figure what is happening? Initially the top is rotating around z-axis. Top was rotating around z-axis. Now when was rotating at the full speed, so it is forming a cone, this structure of the cone, and as soon as its speed is decreasing, it is again sweeping out a cone. You see here dotted line shows. So this is the swapping out of a cone. The movement of axis of the top around the vertical is termed as precession. So the movement of the axis. So here the axis is not fixed, it is moving. So this is term, physical term for that phenomena is precession. Note the point of contact of the top with the ground is fixed. The axis of rotation of the top at any instant passes through the point of contact. Another simple example of this kind of rotation is oscillating table fan for a pedestal fan. So either oscillating table fan or a pedestal fan is also the same type of example as of top. You may have observed that the axis of rotation of such a fan has an oscillating sidewise movement in the horizontal plane about the vertical through the point at which the axis is pivoted. That is point O in figure 7.5. Let us see figure 7.5. So this is a oscillating table fan or pedestal fan. So you see, axis of rotation is this one. This is the axis of rotation, and this is also moving with this axis of rotation. With this, so fan is moving with this axis of rotation, and this the whole this part is moving with this axis of rotation. Only the fan, this part is moving with this axis of rotation. Let us move forward. We may have observed that the axis of rotation of such a fan has an oscillating sidewise movement in horizontal plane about the vertical through the point at which the axis is pivoted. While the fan rotates and its axis moves sidewise, this point is fixed. Thus, in more general cases of rotation, such as rotation of a top or pedestal fan, one point and not one line. So remember, one point, not one line of a rigid body is fixed. So in this type of motion, one point is fixed, like pedestal, top, one point is fixed. In top, the point which is where the top is touching the ground, that is fixed. In pedestal fan, these two axes of rotation intersects at point O. So these two axes, this axis and this axis intersect at point O, and this is fixed in this type of rotation. Now let us move forward. In this case, the axis is not fixed, though it always passes through the fixed point. In our study, however, we mostly deal with simpler and special cases of rotation in which one line, that is the axis, is fixed. So thus for us rotation will be about the fixed axis only unless stated otherwise. The rolling motion of a cylinder down the inclined plane is a combination of rotation about a fixed axis and translation. Thus, the something else in the case of rolling motion which we referred to earlier is rotational motion. You will find figure 7.6a and b instructive from this point of view. Both these figures shows the motion of the same body along the identical translational trajectory. In one case, figure 7.6a, the motion is pure translational. In the other case, 7.6b, it is combination of translational and rotation. You may try to reproduce the two types of motion shown using the rigid body like a heavy book. So let us see both of these figures. So in figure 7.6a, motion of a rigid body which is purely translational here. And in figure 7.6b, motion of a rigid body which is a combination of translational as well as a rotation. Next, we now recapitulate the most important observation of the present section. The motion of a rigid body which is not pivoted or fixed in some way is either a pure translational or a combination of translational and rotation. The motion of a rigid body which is pivoted or fixed in some way of rotation is rotation. So this is very important concept. You have to remember this. The motion of a rigid body which is not pivoted or fixed in some way is either a pure translation which is not fixed, might be a pure translation, or a combination of translational and rotation. The motion of a rigid body which is pivoted or fixed the motion of a rigid body which is pivoted or fixed in some way it is rotation. So if the axis, so here in the first part, if it is fixed, if it is not fixed, axis, not fixed axis, then it can be translational, or translation also it says translation. And second part, translation, pure translation, it can be pure translation or it can be a mixture of rotation and translation. And the other case where the axis is fixed, in that case it is only rotation, no translation. The rotation may be about an axis that is fixed, that is a ceiling fan, or moving, that is oscillating table fan. We shall in the present chapter consider rotational motion about a fixed axis only. So in this chapter we'll just consider the rotational motion about a fixed axis only. So let us keep till here in this class because video is getting too much longer. It is difficult to upload a longer video with my net speed is not so high. So let us keep till here. In the next class we'll start with center of mass. I think the participants are with me. At any point in time, if you are not getting, if anything is not understood, then please write a comment. I will go through those topics again in our next video. Please write a comment about your experience how you are finding this lesson. It is guaranteed that if you follow this video, we are not skipping a single step, single line. No one can stop you in getting more than 95% if you study in this way. Just you watch our videos, make notes of important thing, and before the exam just go through those notes. That is sufficient for getting more than 95%. People who are preparing for NEET and IIT exams or any objective exams, we are going line by line. So all the competitive exams in India, they follow ncert, and if you are not skipping anything, then it is a good chance that you can secure those exams. And any hidden lines, hidden meanings between the lines will come, I will explain separately in the same video. So till then, goodbye. Please like this video and write a comment how your preparation is going on. Thank you very much. See you on the next video soon.